Hey guys, this is the last topic for, or last two topics for 3.1. We're going to cover both at the same time. Number 4, apply the compound interest formula. And then number 5, define and understand the number e and the natural exponent function. So number 4, the compound interest formula, is a super famous formula actually. Einstein famously said that compound interest is the eighth wonder of the world. Or is it ninth? One of the wonders of the world. And those who understand it will reap the benefits, and those who don't will pay for it. I'm misquoting him, but that's paraphrase. Anyways, it's an amazing thing. What it represents is it represents a future value amount, total amount that you end up with if you were to invest some starting value p at a particular rate for a particular number of years t, and given a period of compounding n. So think about it like you're buying like some kind of investment, and you're just letting the money sit, and that investment is gaining compound interest, and that's what you're going to end up with. So a here is the total amount, right? That, or we also call it the future value because it's how much you're going to end up with at the n in the future. T is time, always measured in years. That's this t. P is the initial amount, sometimes also called the present value, or also sometimes they call it the principal. It's how much you start with, or how much you invest to begin. R is the rate of growth, or if it's, I guess it could also be decay if you have it as a negative number. And then N is the number of times per year that interest is compounded. So number of times per year that you compound. So that means N, if you're compounding annually, N would be 1. If you're compounding quarterly, N would be 4. If you're compounding monthly, N would be 12. Daily, you typically use 360 if you're doing this in like a business context or a financial context. They might use 360 or 365 depending on who you ask. Let's see if they say in the question. It doesn't say in the question. So I guess since it doesn't say, we'll just stick to the normal 365 because that's how many days there are in a year. But just be aware, a lot of times people will use 360. I think it's because it evenly divides months into nice like 30-day months if you did it that way. So yeah, just be aware. But actually, honestly, doesn't change the outcome that much if you use 360 or 365. It's gonna be just like a small fraction of the overall value. Okay, so that's a compound interest formula in a nutshell. And what happens is if you compound continuously, so as n gets closer to infinity, or as n goes to infinity, that means you're compounding every microsecond, even faster and faster and faster than that. Then this formula reduces to this over here. Oh, I'm sorry, guys. This is it's an old version. You can ignore this little 0 on the bottom because I didn't have it up here. The 0 is there just to indicate that that's the starting at time 0, but you don't have to have it there. Okay, so this is just p times e to the rt. That means this p, of course, the same p down here. So let's just kind of black that out for a second so we can ignore it and focus in on the rest of the equation. That means this 1 plus r over n to the nt, that's the part that becomes e to the rt. So this all reduces as n goes to infinity. It reduces just to e to the rt. Why is that? Well, that's because e is a constant, but that constant comes from this definition right here below. E is the value that pops out when you take this 1 plus 1 over n to the nth power as n goes to infinity. It's like, this is one of the ways to define E. E is like super famous, super important constant in mathematics. Right up there with pi, maybe even more important than pi. You'll see its value more and more if you go on to take calculus later. But for now, it's kind of this miraculous thing that pops out, right? When you take n going to infinity of this expression, 1 plus 1 over n to the nth power, then you end up with this constant value, 2.7182, blah, blah, blah. And that number does not change. It's kind of similar to how pi is, or pi is about 3.1415, blah, blah, blah. But it doesn't change. It's a constant number. So it's not a variable. It's not going to be 2 now and 3 later. It's always the same number. Okay? So does that make sense? So coming back to this, you see this 1 plus the if you look at this compound interest formula, you see this 1 plus something over n raised to the nth part, right? So that part is the part that turns into that e. Okay, let's move on. Last thing to note for the theory part is we call e to the x the natural exponent function. That's because it's got the natural constant. We call e the natural constant. And it's raised to the x power. So if you think about that exponential function we talked about at the beginning in the first video, it was a, general form is f of x is equal to a to the x. If this a happens to be e, then we call it the natural exponent function. Okay, let's move on to the questions. Questions are just really about compound interest. And honestly, it's just kind of a lot of calculator work for the most part. But we will along the way see how we access E on our calculator. And real quick hint, you access it by pressing the E button on your calculator, basically. Okay, number 17 says a deposit of $10,000 earns 8% annual interest. So this is how much you're investing, right? 8% is the interest rate. Let's just pause right here for a second and start labeling our variables here. So this 10,000 is what you're starting with. That makes this the P, yeah? 8%, that's your rate. But 8%, we want to write that as a decimal for the purpose of inputting into our calculator. So R equals to 0.08. Annual interest, and it says annual interest, you know, when you do these interest and you start compounding more than once per year, you basically just divide that interest, and that's what you see up here in the formula, where you're dividing by the number of compounds, right? Oh, sorry, not there. You're dividing by the number of compounds. So you're basically splitting that interest rate into the number of compounds. Okay, anyways, let me also write the formula so we can just have it as a reference here. So the ending result is the principal times 1 plus r over n raised to the nt. This is the compound interest formula. Okay, so it says next says find the amount in the account at the end of 20 years. So that means t is 20. Remember, t is always measured in the number of years. And the amount of interest earned during the time if interest is compounded. Okay, so we're trying to find the amount. This is, I'm going to put a little blue highlight over what we're trying to determine. We're trying to determine the amount, and the amount that is talking about the A, right? The future value. This is here. The thing that we're after is the future value or the total value. So, and then we also want to know the amount of interest earned. Interest earned is just going to be the difference between the total amount and how much you started with, right? So here, let me just write a little note. Interest earned. And if you think about it for a moment, that makes sense, right? Interest earned is just how much you ended up with at the end of time, whatever, how many years you invested, 20 years in this case. And you subtract how much you started with, how much you initially invested. The rest that you earn is all interest. Okay, so we're going to do annually, quarterly, monthly, daily, continuously. And for this, I'm going to bust out my calculator. See if I can do split view here. Oops. Okay, here we go. What the? Oh, wrong one, sorry. Oh, there it is, there it is. Okay, so I have the formula already pre-typed here. And you know, if you're using the Desmos calculator, you can find Desmos calculator online. Actually, I like the online version better. It's easier to use. And it's super user-friendly. Of course, you can use a scientific calculator, but you know, for a test, I will allow you, if you want to use the Desmos calculator. That's the only website that we're going to allow. Otherwise, you can do the same thing on your scientific calculator. But here I have the formula typed in. On a normal calculator, what you would do is you just type in that same formula piece by piece. So 10,000 would be the principal, right? Or the P times parentheses 1 plus, and then you have your R, which is 0.08, divided by N, which is in the first case for part A, it's annually. So just be divided by 1. And then you go to the exponent. Exponent is this a to the b function for me. Some people have x to the y. Some people have a little caret symbol on your calculator. It depends on the calculator itself. And then raised to the nt. So nt, when you do the exponent here, remember to keep it in parentheses. Otherwise, the order of operations is not going to be followed accurately. So n here is 1, right? Times t, which is 20. So here we go. Okay, and you pop out with 46,000. Let me write it like this here. Okay. 46,609, and we'll run to the nearest cent here. And 57 cents. Okay, that's how much was the total earned. And then let's also do the answer. That answer. And we're going to subtract. We're going to subtract the initial amount of 10,000 that was invested. Okay, that was actually an easy calculation because you just reduce this first number by 1, right? So that's the total. And then reducing that by 10,000, 36,609.57 is the amount of interest earned. So this is a pretty, this is a pretty normal interest rate that you would get, right? If you were to invest in some kind of say stocks and bonds or something, 8% is a reasonable estimate. Historically, stock market has like an annual return of 10%, sometimes higher, sometimes lower. So it's pretty reasonable thing, right? And then you invested 10,000, ended up with 46,000. That's after 20 years. You'll see actually that number, like the gap, percentage gap increases really faster as you go for longer years. So if you can invest for longer than 20 years, you'll see even more of a dramatic change. Okay, within the Desmos calculator, there's a little trick I can actually use though. Instead of having to type this whole thing out every time and then after retyping all those numbers, if I'm using this particular calculator, it's got this nice feature where if I have the formula entered once, I can actually just tell it what the variables are and it's gonna spit out the answer. So I'm gonna write P. Oops. So this is unique to the Desmos calculator, but I'm gonna use it because it makes my life easy. PR, and make sure if you're doing it this way that you match the capitalization as well. Match everything. Okay, so P was 10,000. R was 0.08. N was, okay, N is going to be quarterly this next round. Actually, let me just do the last one to confirm. T is 20. And this one is, wait, what am I missing? Oh, sorry. My formula somehow got messed up. Or I didn't write the NT in the beginning. Okay, and this one is going to be capital A minus 10,000. Okay, so now just look at the value. See how the top value appears right over here, right there, yeah? And that matches what I had over here. So all I have to do now is just update the variables and it's gonna update for me automatically. And the only variable I'm changing here is the number of times compounded per year, right? So here, I'm just gonna, I did annually, next is quarterly, monthly, daily, and then continuously. Okay, so all I have to change is the N. For quarterly, N is gonna change to 4. So for part B, if I put in 4, the result is right there, yeah. 48,754.39. So you see that you get a little benefit, yeah. After 20 years, difference of 2,000 is not really that. It's not really that significant to have to wait 20 years to see that gap to me. From the difference from compounding monthly versus annually. Of course, it is better, right? It's better. Better to compound more if you can. but really not super different. You get 38,754.39. What this tells me too is like if you're able to make your investments and you have some return and then you reinvest at the end of the year, you can reap the benefits of this compound interest. Or if you reinvest every quarter, it's just a little more work, you can do it. You can get this quarterly interest compounding feature happening. Maybe some other instances you have just it done automatically, where you have automatic compound interest happening, which is better. But I'm just rambling now. Okay, let's talk about the next one. Monthly, N would be 12. And if you do monthly, then your result is 49,268.03 to the nearest cent. And then interest earned would be 39,268.03. Okay. Let's move on to daily. I said for daily, we're going to choose, go ahead and use 365. Some people might use 360. Just be aware of that. Okay, and then now we see the difference is starting to be less and less, right? 49,521.64. That's the total amount. And then minus 10,000 is the interest earned. Okay, and then moving on to the next one is continuously now. Continuously. Okay, so for continuously, now we have a totally different formula. I'm going to actually delete all this stuff. Oh no, I shouldn't have deleted everything. I still need the time. I don't need the N actually. N is the only thing I don't need. Okay, we're not going to use this formula anymore. We're going to use PE to the RT. If I'm using the Desmos calculator, then it's as simple as typing in the letter E. It might also be in functions. Oh yeah, it's also in functions. So maybe it's better if I show it to you more like how it would be on a normal calculator. So normal calculator, you're looking for the E here. You see that E? So you're looking for that symbol somewhere in your calculator. It might be, it's like over there on the left. It might be that you have to press like a second button to get there. But here E, yeah, and then you can go back to your exponent button and then to the T here. Here's what I want. To the RT, sorry. PE to the RT. Okay, and you see it's comparable, right? 49,530, comparable to compounding daily. Okay, if you're doing this without using the Desmos calculator and you're just doing it kind of normal way by inputting the numbers, then you just do it like this. You just do 10,000, that's your P, right? Times, and then find your E. Sometimes they have E, you see this right here, right? Highlighting things. Sometimes you have a button E to the X. That takes one step out of the process for you. It already gives you E, and it tells you it's waiting for the exponent. All calculators are a little different, so make sure that you understand how your calculator is doing it. Sometimes you might see EXP as well, instead of E to the power or whatever. Okay, E to the 0.0. Sorry. For exponents, I want to make sure I have my exponent in parentheses. RT, so 0.08 times 20. And then close my exponent parentheses. And you see it pop out right there, yeah? So E, oops. This is E, letter E for the step E, continuously, not to be confused with the natural constant. So the result is 49,530 and 32 cents, which means interest earned is 39,530.32. Interestingly, the number of compounding occurring between E versus D is infinitely different. Like in letter D, we compounded exactly 365 times, right? But in letter E, we compounded in incomprehensible number of times. We compound it infinitely many times. So it's like comparing 360 to a billion, trillion, quazillion, quintillion, and even more than that. But the overall result, notice, is really not that far off, right? 49,520 versus 49,530. It's kind of a miracle of the e, actually, being the result of that 1 plus 1 over n to the n, as n gets to infinity. Okay, let's... Oh, actually, let's just keep it like this. So that was problem 17 we just finished. Yeah, that one's done. We're now going to move on to 18 and 19. Let's erase all this. We're just going to keep our calculator open for this one. Okay, so number 18. Federal Saving and Loan offers 6.375% annual interest compounded daily on certificates of deposit. What dollar amount deposited now would amount to $40,000 in 3 years and 2 months? Okay, I see. Okay, so let's just kind of label what we have so far first. So 6.75%. That one's pretty obvious. That is your R, right? So R equal to 0.0675. 75 comes from 0.75%. Oh, oops. I'm off by a 0 here. 0.0675. And then annual interest compounded daily. Compounded daily. That means that the n should be 365, right? Or 360, depending on who you ask. Dollar amount deposited now is what we're after. Okay, so let's put that as a question mark. What dollar amount should be deposited now? In other words, what is P? We don't know. P is what we're trying to figure out. A little bit different style question where we're not solving for A this time. Would amount to $40,000. So that is the A. Yeah, A is 40,000. In 3 years and 2 months. 3 years and 2 months. That'll be the time. Time is 3 years plus 2/12. So I'm going to write it like this. 3 and 2/12. Why 3 and 2/12? Well, because 3 years plus 2/12 of a year, right? 2 months. Okay, so there you go. And okay, now let's take our original equation here. P times 1 plus R over N to the NT. And now we want to solve it for P, right? So how do I solve it for P? Well, I just take this and divide it by all of that. So think about it like this. It's like I'm doing this. Taking this piece and just dividing A by all that. Oh, without the P, sorry. Just going to divide both sides by this. You're going to end up with A over that, right? So let me show that in the normal algebra way. So A is A over 1 plus R over N to the NT is equal to P. Okay, so this is what we're going to use to solve for a P. It's going to plug all these values into this formula here. Okay, easiest way to do it to me is to just type it into my Desmos calculator exactly as it's written. P is equal to A. Just be careful with your order of operations here. Make sure you include parentheses where you need them. 1 plus R. Of course, you could do this with the numbers if you prefer, but I like to just use the letters as placeholders. You know, as I'm talking to this, actually, I should show you the other way. I should show you the harder way, just because let's say you're only using your scientific calculator, then you need to know how to do that. So let's do it that way. Okay, so the A goes on the top. A in this case is the 40,000. So 40,000, right? divide by parentheses 1 plus r is 0.0. Oops. Missed that. 1 plus 0.0675 divided by n, which was 365. Close that parentheses. And then that inside that parentheses is raised to the, and then parentheses for your exponent. N is 365 again. Times, okay, I need another parentheses because I'm going to do addition here. 3 plus 2/12. Close the two parentheses. And then there you go. That's what pops out. Okay, so you notice that the value is relatively high compared to our first question, right? So the ending result is 32,302.65 to the nearest cent. Relatively high compared to what we had in question 17. That's like not that far off from 40,000 itself. But the reason for that is that we only have 3 years, a little over 3 years to accomplish that. So in three years, you're not getting much of the benefit of the compound interest. The power of compound interest comes with time, because just think about the exponential function graph, especially with a relatively low rate like this. It kind of looks like this. Time 0 right there at the axis. It kind of like starts slow and then suddenly it just shoots like almost straight up. So, but towards the beginning, you don't see that compound effect too much. Okay, that was question 18. We just finished, yeah? We just solved 18. Okay, so now we're doing question 19. Okay, let me try to zoom in here. Let me clean things up first. Okay, number 19. Investor wants to have a retirement nest egg of $2,600,000 and estimates that her investment will grow at 6% compounded continuously for 40 years. What amount should she invest now to achieve this goal? Okay. So she's thinking ahead, gonna retire in 40 years. Thinking way ahead. Good job thinking early. But that's really gonna benefit her, that time. Let's start the usual thing. Let's highlight what we know, okay? She wants to have a retirement nest egg of 2 million. That means that is the N total value, right? That's the T. Oh, I'm sorry. I was thinking T for total. Actually, it's A for total because T is reserved for time already. Estimates her investments will grow at 6%. So 6%, that means that is her R, right? R is 0.06. Compounded continuously. Okay, continuously means we're going to use that continuous compound interest formula. And for 40 years means your T is equal to 40. All right, so we're using the formula P is equal to, A is equal to P times E to the RT. Just now we were told A, we were told R, we were told T. Remember, E is just a constant, so the only thing that is missing is the P. That's what we're trying to figure out. And if you look, what amount should she invest now is the question, right? So that is the P that they're asking for. They're saying, what is P? Okay, so we're using that formula, right? Except we want to solve this now for P, because that's the thing we're missing. That's the thing we want to know. So it's similar to last time. You're going to divide both parts by this portion, right? Divide both by that, and you're going to end up with the result. So let's write that out. A over E to the RT is equal to P. That's what we want to know. This is what we're going to plug in. So new calculation here. Oh, I should just press clear. Okay, here you go. A is 2,600,000. Yeah. and you're dividing that by e. Where's e? Let's look at my functions. E, and I have the exponent e. So e to the x, e to the, what is the x? Put my parentheses. 0.06 is the r times t, which is 40. And then close my parentheses. Okay, you see what I typed in? 2,600,000 divided by e to the 0.06 times 40. Make sure your exponent is in its own set of parentheses. And the result is 235,000. 235,000. P is equal to 235,866 and 68 cents to the nearest cent. So pretty cool, right? To end up with 2 million at 6% interest, you just start with 235,000. So that's a gap of you get over 10 times, right? You get over 10 times the initial investment. Now, what if this wasn't 260, 202 million? What if I just wanted a measly 1 million? Well, then you start with 90,000. Okay, I was just for fun, that last part. Okay, that's it, guys. So hope it's making sense to you. If not, then feel free always to meet up. Set me a schedule a Zoom call or office hours on the link in the syllabus, or you can just email me. All right, guys, have a good one.